Alright, what's up guys? In this video we're going to pick up with some vector calculus and we're going to evaluate another surface integral here. So we're asked to evaluate the surface integral that we're given here, 5x plus y minus 2z ds. Basically where s, which represents the surface, is given to us by z is equal to x plus y over 2, and the range for our two variables here, x and y, well, x is going to be between 0 and 2, and y is going to be between 0 and 5. So the way that you evaluate a surface integral depends on how the surface is given to you in the first place. In this particular case, we're given, the surface is given to us by z is equal to some function g of x, y. Or in some cases, as you've seen in previous videos, the surface will be given to us and we'll need to do it by parameterization. Now, the evaluating a surface integral where we do it by parameterization is a little bit more lengthy of a process. But when you get down to actually dealing with the integral itself, it's actually not that bad. For cases like this one, where we're given the surface as a function of, or when we're given the surface is equal to z, or we're given the surface is z is equal to g of x, y, all we have to do is use the definition for the surface integral. So although this may be a little bit of a quicker route, it is often the most difficult route because of the often messy square root that can cause a little bit of problems. So in this case, we're just simply going to use the definition of the surface integral. Looks like my pen is going out, so give me 1 second. Okay, so if we want to evaluate a surface integral using the definition of the surface integral, it's just going to be the surface integral f of x comma y comma z ds is equal to the double integral, and then we'll have f of x comma y comma g of x y, or g of x comma y, multiplied by the square root of the partial of g with respect to x, squaring that, plus the partial of g with respect to y, squaring that as well, and then adding 1 and dA. So that's the actual definition of the surface integral. So this one is a little bit more straightforward, but it does get a little messy sometimes with that square root. One of the things I do want to point out when you're dealing with problems like this, when you're dealing with surface integrals, where you're just simply using the definition, that's how you're going to evaluate it. It's very important that you make sure that you simplify as much as possible. It's like if you hear all the time in life, you know, when they say, you know, you commit a crime, you'll be prosecuted to the fullest extent of the law. Well, in the case of certain integrals in math and calculus, you need to simplify as much as possible, because if you don't and you just try to leave things as they lay, you're going to have a hard time. So clean it up, make it look nice. That way the integration is a little bit easier. Alright, so all we have to do is use the definition. So we're just going to take our time and do that. So let's just go with what we got. Remember, you can always tell the difference between a surface integral and a double integral by looking at the differential. So this is what we got. So we got our double integral, and we're going to stick everything in. So it's going to be 5x plus y minus 2. And remember that z is equal to g of x, y. That's what the function is. So we just stick that in there. So it's going to be x plus y over 2. And we'll multiply that by that messy square root and everything under it. Okay, so we'll begin by taking the partial derivatives. So let's go up here to our function z is equal to g of x, y. We take the partial of that with respect to x, and if we do that, we just get 1. And if we take the partial with respect to y for that, we get 1/2. So we're going to stick all that stuff in. So this would be 1. We're going to square that. And then this would be plus 1/2, which we're going to square as well. And we're going to add 1 to it. and then dA. Alright, so now let's just go ahead and attach those limits of integration now. So now we got the double integral here, and we're going to evaluate this dy dx, so that means that the outer limits are going to be from 0 to 2, and the limits for the inner integral here are going to be from 0 to 5. Now you have to make sure that the integrals match up with the order in which you're integrating. In other words, since we know that the range for y is from 0 to 5 and we wish to integrate with respect to y first, well then we can't have the ranges for y's on the outer integral because we're dealing with y first. So you have to make sure that you know, you're doing that. Okay, so let's go ahead and simplify this side over here. So this would be 5x plus y minus 2x minus y, and we'll multiply that by this messy square root. So it looks like we're going to get 1 plus, and then don't forget that when we're doing 1/2 squared, we're squaring the 1 and the 2, so this would be 1 over 4, and then you'll add 1 to that, and again this is going to be dy dx. Alright, so let's clean it up a little bit, and make sure you have your calculator as well so you can check your answers. And we're going to clean it up a little bit and see what we get. Now the great thing is, oftentimes what happens under the square root is it actually works out to be quite nice. So essentially what we'll have is, after we take care of everything under the square root, we got 1 plus 1 over 4 plus 1, that's 9 over 4. Now remember, we can take the square root of 9 over 4, because if we take the square root of 9 over 4, we'll get 3 over 2, because taking the square root of 9 over 4 is the same thing as taking the square root of 9 all over the square root of 4, so that gives us obviously 3 over 2, which is just a number, it's just a constant, and we can bring that out. So now we got our integral from 0 to 2, and after we do the simplification, this is what we got now. So we got 3x multiplied by 3 over 2, and then this is integrated dy dx. So all I did was clean it up. Okay. So now we just deal with the double integral. So remember, for our double integral, we integrate respect to this variable first, treating the other as a constant. Then we'll integrate with respect to x after that. Alright, so what that means is we'll have the integral from 0 to 5, and if we simplify the inside here, we'll have 9 over 2 multiplied by x, and we'll begin by integrating that with respect to y. So since we're integrating this with respect to y, we're treating all of that as a constant, considering that there's no y's in there. So this becomes 9 over 2 x multiplied by y, evaluated from 0 to 5. So if we stick in the 5 using the fundamental theorem of calculus, we'll get 45 over 2 multiplied by x. And sticking in the 0 obviously just gives us 0. So we'll end up with 45 over 2 multiplied by x once we integrate with respect to y first. And now we just move down to our last integral, which will be with respect to x. So we'll have the integral from 0 to 2, and then we'll just have 45 over 2 multiplied by x. That's what we're integrating, and we're integrating all of that with respect to x now. Okay, so we'll simply use the power rule. Remember, 45 over 2 is just a constant, it's just a number, so that can come out front. If we use the power rule for integrals, this will give us x squared over 2, and it's going to be evaluated from 0 to 2. So using the fundamental theorem of calculus again, we'll stick in the 2, so that's going to be 2 squared, which is 4. We divide that by 2, we'll get 2, so this will be 2. Sticking in 0 just gives us 0, so we'll just end up with a 2. So now we just take the 45 over 2, and we just multiply that by 2, and this obviously gives us 45, because we know that 45 times 2 is 90, so then we'll just essentially simplify it and divide that by 2. It just gives us back to the 45. And that would actually be your answer. So your final answer for the surface integral that we were asked to evaluate, which was 5x plus y minus 2z ds. Your answer here is simply going to be 45. And that's how you do it. So maybe this was a little bit of an easier example where we just had to use the definition of the surface integral, and the process for this one wasn't bad, but don't expect them to all be that way, because like I said, that square root can cause problems depending on the type of problem it is. But that's essentially how you do it. Also, make sure that you take your calculator slightly before turning in your work and check your arithmetic. I see a lot of students not doing this, and they end up losing points. And as you can see here, I just went back and checked my answer. Even though I knew the answer was 45, I checked anyway. And you want to make sure you're doing that. So that's the answer. So I will see you guys next time. Let me know if you got any questions about it. See you.